Hello everyone, welcome to Instrumentation Insights Hub, your one-stop destination for in-depth knowledge in instrumentation and automation in the oil and gas industry. I'm your host, a passionate professional, a YouTuber, and enthusiastic engineer with over 12 years of hands-on experience in this field. In line with the last video, today I came here with the new topic hazardous area types of protection techniques. In the last video, we discussed about how we classify area as per different regulation and standards. Today, if we are going to install any equipment in hazardous area, what are the protection technique so that that equipment is suitable to install in that particular zone. So let's start. And also request to subscribe or like and share this video to all the colleagues so that they can be benefited with this video. This slide is the sum up of coming all the 12 slides. If you understand this slide, then there is no need to go through in the further 12 slides. I usually prefer to provide the data in tabular form only. The reason behind that is to save your time and give the comparative view of all the techniques. So you can see that what are the protection techniques available. Protection techniques available is explosion proof EXD, intrinsically safe EXI, pressurization EXP, increased safety EXE, oil immersion EXO, encapsulation EXM, flame proof enclosures EXQ. What is explosion proof and flame proof enclosures? We will see. Non sparking EXN. And how it works, application, key features, suitable zones and temperature classes, everything is driven by some standards. So EXD follows IEC 60079-1, EXI-11, EXP-2, EXE-7, EXO-6, EXM-18, 5 and 15, right? So these are the standards based on which these protection techniques are written. Now, how it works. Explosion proof. Ensure equipment in a robust housing to contain an internal explosion and prevent ignition. How we prevent ignition, how we stop ignition to come out in hazardous area? By providing a robust housing. That is a explosion proof. Intrinsically safety. This is a method in which we limit the electrical energy in circuit to come out in hazardous area. Now comes the pressurization. EXP maintains a constant flow of clean air or inert gas to prevent hazardous substance from entering. So if we maintain a certain pressure inside inside some housing, then hazardous gases cannot come inside that containers, and that will prevent some explosion. Increase the safety. Design equipment to avoid sparking or heating during normal operation. That is the increased safety. How we achieve that? We achieved application. How we achieved that? By terminal boxes. If you are using the terminal boxes, then that can be increased safety method. Junction boxes and lightning arresters, right? So oil immersion component immerses components in oil to isolate them to hazardous atmosphere, right? Transformer, large electrical contacts. Encapsulation encases components in a solid resin to prevent, right, encapsulation and oil. In this we immerses components into oil, and in this encases component in a solid resin, right? Sensors, circuit board, small electronic devices. Flame proof exclusion fills enclosed with sand or powder to absorb flame or spark, flame proof, right? And that is the explosion proof, right? Non-spark, ensure equipment does not produce spark or hot surfaces. Electrical equipment in low risk environment applications. Now comes to the application part. Explosion proof, like motors, lights, switches, right? We provide junction boxes, EXD, right? Intrinsically safety instrumentation, sensor, low power devices, pressurization control panels, analyzer, motor cabinets, increased safety terminal boxes discussed, transformer, sensor circuit, and like uh, and so on. Key features, how this key feature is how we achieve that. Explosion proof, thick walled enclosure withstand internal exposure pressure. Intrinsically safety, safe in fault condition, works with Jenner barriers. We use Jenner barriers, right? Pressurization, purging, and monitoring required, suitable for larger enclosure. Increased safety, simplified design, no arching components allowed. Hmm? Oil immersion prevent arcing or sparking from reaching flammable atmosphere. Encapsulation protects against environmental factor including moisture and dust. Flame-proof inclusion contains and cool ignites gases to prevent propagation, right? So, and these are the suitable area in which we can use these protection techniques. If your equipment is explosion proof, then you can use it in zone 1 and zone 2. If you are intrinsically safe, then zone 0, zone 1, and zone 2. What are the gas groups? What are the temperature T1 to T6? I think T1 to T5. Only this one is go up to T5. Rest all are can be used to a high temperature as well. And these are the standards. So I told you that if you refer this file, then this slide, then you don't need to go. But still, if you want to watch some in detail, let's proceed. Flame proof basic design is enclosure is strong enough to withstand internal explosion. Critical aspect, enclosure stand flame path on joints, pressure piling, heat loss of built-in apparatus, electrical device. These are the flame proof EXD. JBs are designed in a way that any sparks or explosion inside it must remain inside this junction box, right? Coming to the increased safety level of normal non-sparking apparatus. So increase safety, we can use some terminal boxes and all, so that the safety is increased. Intrinsically safety, basic design limitation of energy in the whole electrical circuit. Safety circuits are normally supplied from safe area and basically limiting the voltage by Zener diode and current by a resistor. So how you limit the energy to go in to so that the current doesn't go to hazardous area by limiting the voltage by Zener diode and current by resistor. Take into account maximum cable length because of increasing capacitor and inductor, right? So this is the typical design. Blue circuit shall be verified before commissioning as per IC standards. IC moderate capsulation, basic design, molding of the electrical circuit, solenoid valves, printing circuit board, PCB. These are the molded encapsulation. Non basic EX and consist of several subtypes of protection. In most cases, being simplified version of this EX, NA, NC, and NR restricted breathing. Enclosed construction, right, becomes EX, EC, IC as per 7, 1, and 18, right? So remarks, not easy to guarantee NR during life cycle. This is important. Yes. Optical radiation, EXOP, basic design is safety by either limitation of radiation or protection of optical, right? This type of protection is divided in EXOP, EXOPPR, ESOPSH with interlock with, and you can see EXOPIS is inherent safe, limited optical energy, light source channel is physically protected, and OPSH with interlock fiber optic loop monitoring, no return is equal to stop. So these are the buttons. All right. Pressurized, keep dangerous atmosphere outside of overpressure container. Powder, basic extinguish any ignition source in quartz filled enclosure. Example, mobile computer. electronics in quartz keyboard or touch screen intrinsically safe and controlled. Based on marking of now comes the marking of equipment. If you see that this is the marking, standard marking, where 2ex, all right, ex2g exd, this is explosion proof, 2c tc and gb is the epl, explosive protection limit. So I mean, if you see any equipment installed in hazardous area, you must see the marking of the equipment and how to read it. How to read the marking? Now we will see that. EXDB. EX is explosion protected, all right. DB is flame proof, D with layer of protection, B, all right. Now comes the EB, increased safety with layer of protection, B. This is explosion proof also, and this is flame proof also. And coming to EB, IAGB, square bracket, associated represent intrinsic safety with level of protection A. Overall application is because of the insert maximum for equipment protection layer GB. This is the gas group. This is the temperature class. The whole assembly has EPL of GB, so we can use it in zone 1. All right. So this is how we read the markings, you know, right? So thanks for watching. This video is in continuation of the last video. Before that, before watching this video, you can refer the first video as well to know about hazardous area classification. Then you can go through this video to know what are the protection techniques to prevent any ignition source going into hazardous area. Be safe, keep learning, and don't forget to subscribe, like, share, and comment this channel. This will help me, and this will promote my channel as well. Thank you so much.